If you're a quality professional, you've probably felt it already. The developers on your team are using AI agents, and suddenly there's more code landing than you can review, more changes than you can test. And the code you're looking at, sometimes you're not even sure what it's supposed to do. In today's episode, we are talking about the effects of AI accelerated coding on quality assurance. And welcome to yet another episode of the Beyond Quality podcast.
Hello, folks. I'm Vitaly from Case.
Hello, I'm Maria from Regent.
And I'm Anupam from Test Solutions. Beyond Quality is a collaborative community focused on advancing quality practices through open discussion and shared knowledge. And today we are speaking about one of our ongoing research topics titled QA in the Age of AI Accelerated Development, and what happens to testing when agents generate code at scale. And this is a topic that we've already spoken about, but we wanted to return to it because of the research that Vitaly and Lilia Abdulina from JetBrains, they've been furthering this research in the community, and we wanted to return to it because there is so much more that we wanted to uncover. And it also helps that we have one of our co-hosts who has been actively involved and is deeply invested in this research.
Thank you, Anupam. I've just recently, what you've said about testers being overwhelmed with the volume of code generated by developers with AI or AI with developers is very true. And that was the reason why Lilia even came to me to start discussing and researching this. But it's also interesting to see that even though there is so much hype about AI from every single device, I would say, like you can't miss it. It's interesting to see that a couple of weeks ago I was at QA Financial Forum New York, where C-level folks and VPs and directors of huge departments at banks and fintech companies, they were discussing AI and QA in AI era. And I was surprised in a good way to learn that most of the discussions were following the topic of how not to screw things up, how to still be able to validate, verify, and assess that what we are producing has no bugs, and what we are producing is exactly what we want to be producing. Because for instance, with Reachash, he's our customer and he works for Apex Fintech Systems. Their software processes $230 billion every year. And so if they lose just 1 billion of this money, it's not 1 out of 230. No, it's actually their reputation at stake. They will lose all the clients if they lose just one. And this brings an interesting conundrum or interesting topic for them. They cannot allow bugs, so their risk appetite is very low. And with AI, they're seeing high marketing hype saying that, oh, now everything is generated. But rarely people speak about how we test what's generated. So that was why I so willingly joined this research and try to advance it a lot.
Right. So, I think in a lot of cases, the risks involved with AI adoption can almost be like a wipeout risk. Although the productivity gains are significant, even if you say 10x productivity gains, which is what most of the marketing around the topic seems to speak about, if the blow up risk is even 1% or 0.1% or 0.01%, or let's say that's 1 in 1,000, even that sort of a blow up risk is definitely worth considering alongside this 10x productivity gain, right? And it's what a lot of the marketing hype actually loses track of, and that's where quality assurance comes in, right? And today, while we're digging deeper into your research work, Vitaly, I'm very curious to unpack a few of its details. And to start off with, you've spoken broadly about two different types of quality teams and how they work and the impact of AI adoption on each of these teams individually. So walk us through these two types of teams.
Sure. So I've been in IT for 25 years now, and I've consulted very many startups and small and medium companies. I've worked in quite a few already. And in most cases, I would say that I see teams who are on the reactive side. So I have this classification, which is completely made up from my experience. It's not scientific classification, but this is what I see most often. First is reactive teams. Teams who focus on testing what is done. It's like developers do something, they pass this test object to testers, and testers verify. Same happens within the development team. Developers do something, they produce a PR, a merge request, and they pass on to developers to do assessment as well. This is also testing. So reactive, I call it reactive because someone reacts to the test object being passed on to them. And we've seen shift left movement. We've seen agile movement where this reactivity is, where the idea is that we compress this reactivity a bit. So before agile, what used to happen is developers work on something for a few months, then they pass it to testers, and testers are overwhelmed. I've seen countless, at least 10 projects where the failure was not because developers did something wrong, but basically because testers could not test on time, so they passed the system to the customer in a bad shape, and customer rejected the system and sued the company, or just rejected the system and broke the contract. So reactivity is always complex because you can't predict how much time it will take you to test what if the object is huge. So shift left emerged to narrow the reactivity so that testers start considering PRDs, product requirements, as a test object. They start testing before developers start. But still, it's all reactive. Second type of companies is with, I would believe, better engineering culture, where everyone aims to do some proactive measures, and everyone does some proactive measures so that what developers are producing is of higher quality. This means the easiest signs for that, if the company has pair or mob work, if the company has continuous training at a job, like you invite a security specialist to your team, and they sit with the team for a few months or a few weeks, mentoring them how to write more secure code. You invite testers to sit with the developers so that the chance of developers producing bad code is lower. This is proactive. So it's like with reactive, we assess if we have problems. With proactive, we reduce the chance of problems even appearing. And there is a huge, huge problem with why there is so few proactive companies. Proactivity is counterfactual. So with reactivity, it's very easy to say, okay, I as a tester or I as a code reviewer reviewed this test object and I found X number of bugs. You, dear developer, go and fix them. So we can say, okay, there is a provable result of my work, a number of fixes. And it's easy to justify, like we invest more into testing because we want to reduce the chance of defects reaching the customers. We are finding these defects before they reach the customer. It's like we see the ROI of our investments. We found more defects, they didn't reach the customers, we are in a better position on the market. With proactive measures, they are counterfactual. We cannot say that if you and I, Anupam, sit together on a task in a pair, we produce less defects. We cannot say how much less. It's just not possible. So we reduce the chance, but we cannot even possibly argue how many defects we prevented. We simply don't have them. We simply have less of them. And so this is very hard for managers and testers to justify for. This is why I would say that like Deming, he advocated for the proactivity 70 or 80 years ago, and still you can't see many teams doing mob work. You can still see many teams doing creating risk registers before they test. You don't see many teams doing threat modeling in terms of security, like what's going to happen, what risks in security we have. It takes significantly more effort for testers and developers to go and vouch for these activities. So that's the problem.
Right. And more closer to home, there's also research from Barry Boehm from 1981, where in IBM, he already, on their legacy mainframe systems, he already proved that this rule applies. And it also has like a 1:10 relationship between each stage of development in terms of if you shift your testing efforts earlier, you're going to be 10x better for each stage of the development process, right? But Maria, like on the topic of proactive and reactive quality teams, is this something that you can relate to from your experience as well?
Yes, sure. I see that this problem is only accelerating right now. There are, of course, two types of teams, proactive, reactive. And also, it gets more complicated when AI comes into the picture, because the division becomes even more complex when we see, okay, now we not only have reactive and proactive groups of companies, but also legacy heavy companies who are either proactive or reactive, and AI native companies who are implementing something from scratch. And then they also can act differently in this space because of the context is totally different at each company. Sometimes it's okay to commit to some risks. Sometimes it's not. And I see this gap even widening even more right now, and where companies try to adjust to new requirements, when companies try to assess risks with not so much data in place, which is hard. And I completely agree that there is a need for more research in this field to investigate how we can change the process, what we can keep from the best practices from the past, from the pre-AI era, and take it and improve it, and what kind of new things we can implement to make software engineering better, safer, more adjusted to what users need, and how to do it. There are, of course, a lot of ways to improve the process, but it's hard to say. There is no common recipe for everyone, right? Because we're different as humans, we're different, companies are different, the context is different. And what I would like to see to emerge in the future, in the coming future, is kind of a tool set where every company could pick whatever fits best. But it's, of course, best case scenario, and it would probably never happen. But
No, but I think actually there is like definitely, if I look at Vitaly's research, right, like in terms of what you spoke about in terms of proactive and reactive companies, there are differences at the team level, but there are broad principles that affect these teams differently. And Vitaly, you have proposed your model of coordination and rework, right? Like in terms of the two cost factors that apply to proactive and reactive companies. So maybe walk us through these cost models and how they affect these two different types of companies differently.
Yeah, thank you. You've mentioned, Anupam, Boehm's curve, Boehm's famous meme that the later you fix something, the more expensive it gets. I would even apply it to the whole SDLC, so that the more reactive, the more like the later you do things in the SDLC, the more expensive it is. So why I said that agile and shift left, all these things emerged. They were trying to fix the problem of scaling of testing and assessment generally. So with shift left, we move from the very right to a bit towards the left, like closer to the start of the development process. We are still reactive. We are still reviewing the requirements which are produced by product managers, but we do it a bit earlier. So why shift left emerged and why agile emerged? Because people started realizing that the economy of doing things on the right doesn't scale at all. Because the more you load people in the end with quality control procedures, the more you're paying. And I would even argue that there was already a ceiling to the scalability of testing done on the right. So shift left emerged because testing teams could not cope with the amount of load. That was way pre-AI. It was like 15 years ago. Even then, teams realized that they cannot cope with the load of things pushed onto them. So they moved earlier. Practices like, this is reactivity, practices like mob work or pair work, they emerged because some teams saw that if they do things proactively, sit together while doing stuff, so that this feedback loop is even shorter. It's almost instant. Like you are doing something, I'm telling you, Anupam, you missed something, and then you're doing the same. You're telling you the same. So with that, scalability is much better. Scalability of pretty much anything. Joining, like bringing up new joiners to the team. In a classical team, if you bring a new joiner, you're reviewing his or her results, which is again testing after. And this is very complicated. That is why many teams introduced buddies or introduced mentors, people who proactively started improving the chances of this person passing the probation, improving chances that the person learns a lot. So there were already good signs showing that reactive approach doesn't scale at all. Additionally, there was a few studies showing that Amdahl's law, the law of parallelization in CPUs, applies to companies as well. So that there is always a limit of how many people in parallel can be working in a team on a product. Because then coordination costs are just skyrocketing. Imagine a team of 50 working on one piece of code. Coordination would be ridiculous if they work on parallel. Same for teams working on the same product, like they have to break it into microservices. So in traditional way of work and then test, work and then coordinate, there is a limit to scalability. There was a limit of scalability.
Let's talk about that a little further, right?
Yeah.
Like, I mean, you spoke about 50 people coordinating on a task. Let's start with 2 people coordinating on a task.
Yeah.
The number of communication channels between 2 people is 1, because that's just the channel that goes between these 2 people. And when you have another person in the mix, you have A, B, and C. The number of communication channels is AB, BC, AC, ABC.
Yeah.
So at least those are 4 communication channels. And we've seen that we've increased the number by 1, but we've multiplied the communication channels by 4.
Yes.
And similarly, I think some simple math can prove that coordination scales as the square of the number of people that you add to a particular team, right?
And that is very, very important, because we are humans and AI is not better at this. We make mistakes. We misinterpret the requirements. We misunderstand the system we're changing. So mistakes are inevitable for us, for AI, for anything. And this means that coordination as the process needs to correct for these mistakes. And so what you've just said, Anupam, that as like we are just this quadratic increase of number of channels, it's all good, pretty much okay, when you have people who don't make mistakes, but there are no people like that. So the first mistake which enters this coordination, crazy coordination, it slows down the whole process extremely significantly. Because now coordination has to stop. Everyone else should stop doing their work and fix or help you fix. Otherwise, what you've done will sit in the queue for ages. That was an existing problem with code reviews in very many companies. Code reviews, you could see them in a column piling up and piling up and piling up. Same for testing. It was piling up and more and more and more. Because imagine if tester found a bug, developer needs to stop working on what they were working. Fix the bug in this system they are producing now in a feature, then get back to work. All this slows down the pipeline significantly. And I've seen poor developers who had one feature in progress and 5 or 6 bugs in progress as well. And this is impossible because we have a limit to our context in our head, and it is, I would say, even less than 1 million tokens. So the big problem of scalability, of reviews, of testing was always there in teams consisting of more than one person.
Right. And scalability, I mean, like the challenges of coordination and scalability are inevitable, but I feel like your research also indicates that they affect these two different types of teams differently. So how does coordination function, or how does the coordination function vary between proactive and reactive teams?
I've just described, thank you. I've just described how coordination malfunctions, I would say, in reactive teams. Because if I, as a tester, only wait for things to come to me for me to test, then I'm reacting to them. And we cannot plan how much time exactly, we're not computers, we cannot plan how much time exactly it will take me to test one task. So either and so this means that the queue before me will grow and grow. This means that the load on developers will grow and grow. So this coordination in reactive systems is doomed to have large queues, which is economically not beneficial to anyone. This is what they tried to fix in Scrum when they introduced fixed scope, fixed calendar time, one sprint, to focus on just one problem, to focus everyone on just one problem. They just said, we don't have any other work except for what we have planned for this calendar period. And the original idea was that everyone is focused on the sprint goal. So it's just one task, essentially. Maybe they can distribute between them, but essentially it's just one task. So very many approaches, process approaches that we see failing or succeeding in the last 20 years were designed specifically to work around the scalability problem in coordination between team members in reactive teams. So they introduced more proactivity, more work, etc. So I would say that it is just inevitable that teams would have to be more and more proactive. By proactive, I mean sit all together on increasing the chance that what we are producing now, this one thing, is done as soon as possible, in as high quality as possible, understanding what needs to be done and doing it right. So in proactive teams like that, if you, Maria, are a product manager, if you, Anupam, are a developer, and I am a tester, if we three sit together on one task, on only one task, it is well proven that our coordination will be, it is theoretically and practically proven that our coordination will have almost zero delay. We just sit together on one task. This is essentially what mob work, ensemble work is about. We sit on one task, all three of us. We reduce coordination ridiculously. It's almost zero cost of coordination because we are just chatting about what we're doing. And there were very many proofs that this type of work reduces the number of bugs because we coordinate all the time. You are testing, or I'm testing your code all the time while we're working on it. And what's really, really peculiar is that scaling here is much easier because we can add another person to our mob, to our ensemble. And this person will enjoy free coordination with us because they will just input more valuable information into our process. A good tester will instantly start spotting more issues that we are producing in the code, and we will fix them straight away. This type of work, coordination, has very little coordination costs, and that is why it scales better. Of course, to a limit. You can't have more than, say, 8 people working on one task. So you will still have to split the features. But there is more theoretical work behind this. There is even the hypothesis that if a team of if the team of 8 skilled or 7-8 skilled engineers are working on something, and if they can't cope with it, then the users will not be able to cope with it. There is a hypothesis like this as well, because users cannot digest more than, let's say, 100 features per month. They don't want to digest more than 100 features per month. So there is always a limit to how people use our product. But this hypothesis is outside of my research. I'm just saying that with reactive teams, scaling is skyrocketing. Scaling costs are skyrocketing. You cannot scale a team of people working in parallel and reacting to each other's work to 50 people. Of course, you can't. I would even say that, in my experience, even 8 people is a problem, because I've seen very many teams of 8 engineers working in parallel, and I've seen queues in all they do. Code review, testing, deployment, everything has lots of queues. And this means it has lots of rework, because when there is queue, there is always rework. If you create a pull request to a branch which is a year old, I cannot even possibly merge it, right? Of course, it's an edge scenario, but still, the more time the thing is branched from main, the harder it is to merge it. So I will have to rework a lot.
Right. I mean, like, what I'm gathering from what you're saying about coordination and scaling is that scaling automatically produces a lot of work in progress. And with reactive teams, this work in progress tends to get bigger. And the bigger the work in progress is, the more delay there is to feedback to quality, the more difficult it is to get the right context to analyze and fix whatever is in work in progress or move it along. So it's almost like a vicious circle whereby you increase the number of amount of work in progress, and because of that, your velocity reduces, and because your velocity reduces, you increase the number of work and the queue even further, right? So that's
Absolutely.
that's the kind of spiral that you're alluding to when it comes to scaling with a reactive approach.
Yeah, and we see this all the time. Just one second. We see this all the time with practices like bug bash. Let's stop our work and let's do just bug fixing for a month. Or let's stop our work and let's do bug fixing sprint for developers. We see this all the time, and people advocate for that. I do agree that it is important sometimes, but I would argue that fixing just the system, so the symptom, doesn't fix the system problems. Sorry, yeah.
Right. And what I was alluding to is, like, when we look at proactive teams, we are arguing that the coordination costs by design are kept lower, and therefore the work in progress is also lower because everybody is in context, and in the absence of somebody else, the team can still proceed because they already have all the right information. Is that correct?
Very true. And this is a very, very interesting observation, that when people work together, they learn the system that they're working on from different angles in a much better way. Stafford Beer, in 1940-something, he was working for the British Navy, and he was one of the first cyberneticians who suggested cross-functional teams of various expertise to work on one single problem. And he was an extremist in that. He was trying to help British Navy to successfully bomb the submarines, the German submarines. And he invited biologists, marine specialists, astronomers, and many other specialists onto the team, designing how to bomb the submarines. And he was successful in that, because he said that one person, one specialist, a bomber or whoever, like, he's always going to be biased. So this is what we are seeing in cross-functional teams as well. If I work with Maria on one task and Maria is testing it and I'm developing it, we are much, much more productive in terms of quality and in terms of the speed. Because I'm not going to be reworking what she tells me later via coordination. I'm working on it right now in a better way.
Now, let's take this scenario and add AI agents to the mix. What happens?
Oh, this is very fun. What you've just said a couple of minutes ago is that when we work on anything, we understand it. I would say this is a prerequisite. Like, you cannot even possibly tell me, Vitaly, build me, and I'll build it. Like, what am I building? Like, I even don't know if it's a word or something. Like, it's some murmuring, right? I mean, I cannot possibly build this your thing if I don't understand what it is you want. So usually we have PRDs, usually we have requirements, we have some way, some list of what product managers or users want. And we understand this list because we know people. We know what our product manager usually wants. We know what users are, who they are, why, like we know our company, we know our product, we know a lot about a lot of things around this list of requirements. So if you tell me, Vitaly, can you, on our, you can just say, I'm quoting, on our website, can you add test solutions logo? I know what our website means. I know what logo means. I know what it means to add it. I know how the website is built. I know how to technically add it. So I possess a lot of knowledge on what it is you meant. And this is very, very important. We all know with AI now that it's like a prompt magic sometimes. That sometimes when you add more context to the prompt, you get better results. But it is still you who are validating the results against what you meant. Not what you put. Well, of course, what you put as well, but what you meant. You know in your head what you wanted from the LLM system to generate you. And this is interesting because when you and I are working on a system, producing the code ourselves, we learn the system better. We can judge if what we're doing makes sense or not. If you invite me on test solutions system on one of your systems, it will take me time to onboard. It will take me time to learn the system. I will have to fix some bugs to learn what it takes to fix a bug. I will deploy some code to learn what it takes to deploy the code. So I will start building up a mental model in my head. This is what we had pre-AI. We were learning while doing our work. Coding, reading requirements, understanding our users, talking to customer success, doing all the stuff we do at work. We accumulate this knowledge, this comprehension of what we're building. And this knowledge allows us to say, this is bad, or this is good. It's very hard sometimes to even understand why the code smells, because this smell is rarely just about the name of a function. It's often, for a good tester, like, I know users will dislike it. I know our security specialist can say, I think there might be an SQL injection here. Let's review. And it's a huge experience. It's a huge experience and huge comprehension of what we're doing. So with agents, when we tell the agent, go implement those requirements, the agent first, it doesn't have this comprehension. It was trained on everything. The LLM underneath was trained on everything in the internet. And all it does is the approximation. So we cannot rely on agents to have this comprehension of what needs to be done. We cannot even rely that the agent understands our code base when we feed our code base. Because maybe it does, maybe it doesn't. When in all my work with agents, I'm always feeling lucky or unlucky. It's like I know, okay, this time I'm lucky, it generated something good. This time I'm unlucky, I need to reprompt it. This is because the agent doesn't learn. It only sees what's in the context. So the more we use the agents, the less we learn. And this is gonna challenge our SDLC efficiency very significantly. Because when we don't, like, imagine you hiring a new tester. Again, the tester would have to learn the system. New developers, same, they will have to learn the system. With AI, there is no learning. The developers are not producing code themselves. They are relying on the agents. So this comprehension problem, I call it a comprehension debt, because the more we rely on agents, the less we learn the system ourselves, the less capable we are of reviewing it ourselves. And even if we were capable to review it, imagine if you're reviewing 500 lines of code from a developer, now you're reviewing 5,000 lines from the same developer using AI. And I even have a thesis that in order to review the code really well, we need to rebuild it in our head somehow. Even that maybe just the architecture of the code, but we're still building our mental model of the change set to the system. It is possible to build that model. We've been doing that for the last 20 years. Now with AI, it is not possible because 5,000 lines of code in a day, it's not possible to cope with it. And this is exactly what testers are seeing. Coming back to the start of our discussion, the testers are seeing now more and more features, but they don't know how they are built. They don't know if they were built right. They only have to react. And we know that even before AI, reactive scaling was a hard problem, and some teams were overwhelmed with code and new features. Now the problem accelerates. It accelerates 10 times or even more, because in reactive systems, coordination costs much more.
Right.
Yeah, and coming back to the symptoms that you named, Vitaly, about the bad communication channels, bad coordination symptoms, what I see on the projects right now is that exactly the queues are becoming longer, worse, and AI is amplifying this build up even more because, well, code generation is cheap right now. You can generate a lot of code in no time. But then, okay, someone needs or wants to review it. And what developers are doing right now in the teams, they're sitting and reviewing someone else's code that no one understands because they just mostly produced it automatically with the help of AI. And now the PR review queues are huge. This creates the situation when a lot of code is about to be shipped, but no one understands it. Testing teams are struggling to test it because they can't get the same amount of help from development teams. And it becomes a disaster, I would say, because the coordination becomes much, much harder in this case.
That's the classical case of increasing the speed of one car on a congested traffic street.
Exactly.
Increasing the speed of one car will create a worse traffic jam. That's it.
Exactly. So just to summarize what we've been discussing so far, in general, there are coordination challenges to scaling, and the coordination challenges are harder for reactive teams as opposed to proactive teams. And AI amplifies the degree to which these challenges are also harder in terms of it amplifies the work in progress queue and therefore also increases the coordination costs involved. And to the tune of almost a square of the degree to which you scale up, right? Like if you're scaling up to a number of degree of n, the coordination cost scales proportional to n square.
Yes.
And, all of this is, we've spoken so much about coordination, but we touched upon something else called rework. Vitaly, at least you spoke about this. Let's now move to rework, speak about rework in proactive and reactive teams, and then speak about how, let's just talk about rework and proactive and reactive teams for start.
Yeah. I would say that rework is the term describing the problem that happens mostly in reactive teams. Because if I, as a developer, give you Anupam and you're a tester in this scenario, a change set that you see simply doesn't work or has a whole lots of bugs, you spend some time and you pass them on to me. So through the coordination process, you bring the feature back to me. And say I spent 5 days on writing it. Now I have to spend some more days on rewriting it. And in classical quality assurance by Deming and other cyberneticians, this was always called waste. Simply because I'm redoing something that I could have done better from the start. Deming even introduced in Toyota the famous undone cord. The cord in the manufacturing line that any employee could pull so the whole conveyor belt stopped. Simply because The reason was that if an employee sees that a few parts of the car are malfunctioning, are produced in a bad shape, this employee knows that the conveyor belt, the conveyor system is malfunctioning. So since we're seeing bugs in cars, we need to stop the production altogether and fix the conveyor production process so that less bugs occur in cars. So this was exactly what made Toyota production system so one of the things which made Toyota production system so impressively performant compared to others, because they stopped the line. They proved that this makes economic sense to stop the line producing bad stuff, not to have more rework later. Because if you have 10 cars which you have to rework, you will have to rebuild them pretty much from scratch. Same goes for software development. The same principle applies. If I am a new joiner, you would better sit with me so that I produce less mistakes from the start, from the get-go. If I am a developer and I'm bringing more and more bugs, and you're seeing that there are so many bugs in the features that I push to you to test, it is better for you to sit with me and educate me or introduce some proactive measures so that I stop bringing you things that you do bad so that I have to rework them later. Because rework is essentially just wasting resources. And it is very important to separate rework and bugs, because mistakes can happen and they will happen. The only difference between proactive and reactive measures is that with reactive measures, the amount of rework is higher. I will still learn how to build good code. I will still learn how to not make so many mistakes, but I will just rework more. With proactive measures, if you sit with me to work on the next feature, I will learn much faster. Because again, coordination is smaller, faster, and I will learn faster. And with AI, this is extremely, it's just impossible to fix because AI doesn't learn. So rework is higher with AI, as Maria said, simply because AI doesn't learn. So either it creates some good code, and if I'm lucky, I'm reviewing it and everything is okay, and I had time to review it, and I pass it over to deployment, or it creates some bad code, and then I have to review this code, pass it back to developer, and all developer will have to do is reprompt the AI. And again, we hope that we are lucky next time, which not always happens. And then there is a huge problem with AI in testing, because we cannot rely on AI to review the code. We cannot rely on AI to test the code unless we are somehow sure that it understands the requirements and the code better than the AI that generated the code.
Right. And when it comes to rework as well, you are, I mean, I'm guessing it's a situation which is non-linear in terms of a small amount of rework does X damage, but 2x rework probably does more than 2x damage, right?
Absolutely. It's just another queue, but just move to the left. Mm-hmm.
So it functions it also has this non-linear property of scaling that coordination has. So coordination and rework together can be a deadly combination. And with the presence of AI accelerated coding, I think both these are going to get amplified.
Absolutely. That's exactly what is happening now. That's exactly why teams feel they are doomed now. Both with code review. I see developers now all the time saying, I am not doing code reviews. I'm asking an LLM and I'm feeling lucky. Like I'm hoping that I'm lucky.
Right.
And same for testers. Testers don't have time to cope with these queues anymore. And they also hope that they are lucky. And that is why I've already seen 2 websites which collect companies' problems caused by AI slop. Mm-hmm. And that's why GitHub has now reached, at least that's what I've heard, reached 1.9 of stability.
Yeah, that's definitely scary, right? Like the degree to which we have GitHub being down, such a mission critical source of information, and I mean mission critical system for software development as a whole. But now when like let's talk about some of the. Let's talk about how we can deal with this problem of scaling proactive versus reactive and AI before we start winding this conversation down. But the bottom line before we go to the solutions is that if proactive was if proactive was painful and inefficient in the past, it's unsustainable with AI accelerated coding.
Reactive. It was
reactive.
Yes. It was reaching the ceiling, or have reached the ceiling in many companies before AI, and now it is actively damaging the whole SDLC for very many companies, actively damaging to such a degree that developers are saying that they are betraying their ethics. Testers are saying they are betraying their ethics. If they start saying that they don't know how systems work, they rely on AI to do that. And we all know that AI has problems, unsolvable problems. So we need to do something with the whole conundrum, with the whole situation. I would say that the only way, at least that's how it looks to me as of now, is that we need to finally move to proactive ways of working. And this is exactly a few weeks, I've spent a few weeks in this exact mode with my colleagues from marketing. I help them build their own little products. What AI helps a lot is with creating the scaffold, with creating the prototypes. But even there, if you are not an engineer and if you're not working in extremely small batches, chances are that you will have no way to review what AI generated. I tried using Claude Plan Mode autonomously for a night. I tried like 5 nights. All the results were bad. All the results were bad. I had to throw them away. I had to move to, okay, here's the ultimately minimal, like absolutely minimal iteration that I want Claude to generate that I can possibly review and understand. And that was okay. So what I did with my fellow marketers, they possess less engineering knowledge than I do, but they knew what they wanted. They knew the requirements. They were essentially the product manager of what they wanted for their work. And this is how it worked. We sat together on a Zoom call, and we worked with AI. So I asked, say, Berna, like, what's the next little feature you need in this system? And she says this and this and that, and we iterate with her and Claude. We chat with her and Claude, like, what do you think this little feature should do and how it should work? And as soon as 3 of us reached an agreement that we formulated in a markdown requirements file, we asked Claude to generate it, and I asked Claude to generate, separate Claude to generate tests for that, for these requirements. So requirements to tests and requirements to code. And then we see how these converge. So with the number of tests, like 20 tests and feature of a few hundred lines of code, it was very easy to navigate. It was generated within 5-7 minutes, and it was really easy for me to navigate and to ask Claude to fix it. So that was the smallest iteration, like 15 minutes. For 5-10 minutes, we chat with Claude on the requirements. 5 minutes it generates the tests. One Claude generates the tests. One Claude generates the code. And then we see if the tests and code match and work together. So this, in my opinion, is exactly what proactive approach is. And the beauty of it here is that Berna knows what she wants. I don't know. So it's a classical system, a product manager and a developer, an engineer. An engineer doesn't often know what users want, unfortunately. But Berna knew what she wanted. She was the user. We managed, 3 of us, I, Claude, and Berna, we managed to agree on what was needed to be done. I, as an engineer, made sure that the iteration was extremely small so that I could comprehend what's being written by Claude, both code and tests. And I could see if the tests were bad, because I have testing experience. I understand if the tests are bad. Berna could tell me, oh, we missed something. I forgot I didn't tell you about this little thing in this feature. And we fixed it straight away. The beauty of this is that since Claude generates code very quickly, we don't have to wait for me typing the code. So our pair session, or 3 whatever session, wasn't long. So we could iterate on a few features within an hour. And the quality of these little features for her dashboards and reporting was really high. I'm still okay with this code, and I kind of understand it. I don't fully understand it. I don't remember the variables names, but I understand the architecture and how it's tested. And that's, yes, I lose some comprehension, but not much, because the iterations were extremely small.
Right. So, I mean, what you're alluding to is cross-functional teams, small batch sizes, and real-time coordination wherever that is possible. I think,
Yes.
in summary, those are the three things that helped you in building your features for your marketing teams, right?
Yeah.
Now, I'm sure we'll unpack a lot more about this research, but we're out of time for this particular episode. So I'm just winding the conversation down. But this is also a reminder, because we have only scratched the surface of several things that Whitley and Lilia have uncovered as a course of their research. So please do check out the original research artifact, which we link here in the community page. And this research is active, and it needs your active collaboration, because this is a change that is unfolding. And just as we here are only a small set of individuals, we would definitely benefit from gaining your experience, so that we can make sure that our own blind spots are covered when it comes to how we deal with this topic. And so all of this will be mentioned in the show notes, and we will send you links to this. But for now, so this is Team Beyond Quality winding down with another episode, and hope to see you in the next one.
Just one little thing from me. I'm really, really happy to see actually AI introducing these problems to reactive teams. I know it might sound provocative, but I think that it's time for us to stop solving the symptoms with palliative care, but rather start solving the real problems. If it is coordination, let's improve coordination. If it is parallelization, let's improve this. Like, let's try to fix the real problems. And then I would say, if we fix them properly, the use of AI will not be a problem at all. So we'll see.
Great. That is a tough, provocative note to end the podcast on, Whitley, but it's definitely thought-provoking. So thank you for your research. And we will be soon publishing and coming back to you with a new episode. So until then, take care, and stay safe while using AI.
Thank you. Bye.